Okay, so our objective for today, I can solve and graph quadratic equations using intercepts and vertex. I can solve and graph quadratic equations using intercepts and vertex. Let's read it together. 1, 2, 3. I can solve and graph quadratic equations using intercepts and vertex. So, like I said, yesterday was just a warm-up to today. Yesterday we did some graphing, and we already know how to solve equations three different ways, which is factoring, completing the square, and using the quadratic formula, right? And we already know what quadratic equations are, so we don't need a Freyer model, right? We know that there are two variable equations, highest degree 2, and we have our steps. So from our steps, things to point out, it says make sure the quadratic function is in this form, and this form is called standard form. So make sure when we get to the very first part of solving or graphing, make sure we leave it as standard form, okay? Step 2, using the QF, we're going to find how many solutions are in that equation. Now, from yesterday, we saw some patterns, but now with this is going to tell you from the very beginning how many different intercepts will you have for that equation, okay? And then from there, for the third part, we're going to get the x value of the vertex. We know that the vertex could either be the minimum or the maximum of the parabola, right? And from there, we're going to substitute that back into the equation. And in the equation, that's going to give us our y value. So at the end, for the vertex, we will have a coordinate, an x value and a y value to plot. And that is going to tell us where to stop in regards to the minimum or the maximum when we sketch our parabola. Okay. From there, we solve for our zeros. Do we know how to solve quadratic equations? Yes. And then at the end, we use all the information, our y-intercept, our zeros, our vertex, and we graph it. And then from there, I just want to show you a couple things with the line of symmetry. Okay? Yes. For right now, we're going to use this method. Okay? So, with that said, everybody got it? On your big graph paper, please, get that in front of you, top left. I want you to write this example down, example number 1. Example 1. It says, solve and graph. You don't have to write the quadratic equations. We know we're already doing that. Solve and graph using the vertex, x-intercepts, and y-intercepts. Solve and graph using the vertex, x-intercept, and y-intercept. Solve and graph using the vertex, x-intercept, and y-intercept. Our equation, y equals x squared plus 4x minus 5. Y equals x squared plus 4x minus 5. Okay, so just to get started, I'm going to go ahead and do this one. I'm going to ask you to put your pens down, pencils down. I'm going to do one step, and then I'll ask you to copy, and so on and so forth. The second one we'll do together, and then I'll give you one for you to do by yourself, and then I'll give you some more to practice. If you have your pens, make sure you have them handy, because this is the time that we're going to use different colors just to make sure that we understand what we're looking at. Okay? So here we go. It says, solve and graph quadratic equations using the vertex, x-intercept, and y-intercept. And they give us the equation y equals x squared plus 4x minus 5. So to get started, here it goes. Step 1 says I need to check that it's in standard form. I'm going to go ahead and write the step over here on the side. Step 1, is it in standard form? Look at it. Yes. Okay. Step 2. For step 2, I'm going to use part of the quadratic formula to find out how many roots do I need to have at the end once we graph it. So in order for me to have it handy, I'm going to write my quadratic formula up here. X equals minus b plus minus square root b squared minus 4ac over 2a. Okay? However, I'm going to focus on using a couple of things from the quadratic formula. You're just paying attention. The first thing that I need is what's inside the radical, this part. This part is called the discriminant. This part is used so that we can predict how many zeros we're going to get at the end. So check this out. This is how this is used. I write it. This is step 2. B squared minus 4AC. What is B? 4. So this is 4 squared minus 4 times, what is A? 1 times C, negative 5. Okay? What is 4 squared? 16. Negative times a negative. Positive. 4 times 1 times 5. 20. What is 16 plus 20? 36. So, right now, the number's not as significant as the sign of the number. What is the sign of the number? Positive. So check this out. Whenever we have a number such as this one that is a positive, we will have 2 roots. Whenever we have a number that is a negative, we will have 0 roots. And whenever we end up with a number that this number ends up being the number 0, we will only have 1 root. Let me repeat that again. From our quadratic formula, I use everything that's inside the radical is known as the discriminant. I substitute values because it was on standard form. In here, at the end, if this number becomes is a positive, then there are how many roots at the end? 2. If it's a negative, there's 0 roots. And if it's a 0, if this number is a 0, then it's 1 root. Now let me show you why. Do we have square roots of negative numbers? Remember at the beginning of the year that I said in real numbers there is no such thing. These are known as what? Imaginary. Is that correct? Since right now we're still dealing with real numbers, that's why if it's a negative, how many roots are we going to get? 0, because this cannot exist. Are we there? Okay. Copy this, please. I'm going to erase the negative 4 squared. We don't need that. That was just so that I can explain that. Why not a negative? All right. So pens down, pencils down, eyes up here. So step 1, check to see if it's standard form. It was. Step 2, we write the discriminant. And the discriminant, we get it from the quadratic formula. Everybody with me? Okay. Step 3. On step 3, they tell us to use the quadratic formula to solve for the x value of the vertex. However, we're only going to use part of the quadratic formula again. So check this out. I call this the California part of the quadratic formula. Does everybody see the California? Okay. So I'm only going to use this part of the quadratic formula to find my x value. So step 3, I'm going to use x equals minus b over 2a. Let's substitute values. Let's see. Let's do this one together. What is b? 4. So this becomes negative 4 over 2 times what? 1. So therefore this becomes negative 4 over 2, which becomes negative 2. So check this out. Since we need a vertex, that point, which is the lowest or the highest point, is an actual coordinate. Is that correct? Well, guess what? This is our x value for the vertex. X value is what? Negative 2. However, don't we need also a y value? Yes. Well, guess what? Don't we have a y right here? And we just substitute that into the original, and we get our y value. So step 4, this out. Step 4, we write our original equation, which is y equals, but instead of x, what do I write? Negative 2. So this is negative 2 squared plus 4 times negative 2 minus 5. So let me simplify that. Let's see. Y equals, let's see. This is 4 minus 8 minus 5. Let's see. 4 minus 8, that's negative 4 minus 5, that's what? Negative 9. And that's my y value of the vertex. So the lowest part or the highest part of the parabola is going to have to be this point. Okay? So far so good? All right. So step 1, just to double check. Standard form, yes. Step 2, use the discriminant to find out how many roots we need to get at the end. So how many did we say? 2 of them, because this is a positive number. Notice that we did not do anything else with that 36. Do you guys notice that? Okay, don't get confused with that. Some of us get confused with, what did we do with the 36? Nothing. That's just to let us know, to make sure when we graph, we need to have 2x intercepts. If you do not have 2x intercepts, you made a mistake. Step 5, check this out. For step 5, really, Fly? Step 5, we need to solve for the roots. Do we know how to solve these kind of equations to find our roots? Yes, what would be our first step? Substitute 0 for y, so I write it out. 0 equals x squared plus 4x minus 5. And let's solve it together. Let's see, I open 2 parentheses. Factor out the first term. This is x and x. Open my Power Rangers. And what goes at the end? Negative 5 goes on top. That's my product. My middle term is positive 4, which is my sum. So factors of 5 that add up or subtract to 4 are negative 1 and positive 5. So this is x minus 1, x plus 5. And then we write our 2 equations and solve. Is that correct? So I'm going to write x minus 1 equal to 0, x plus 5 equal to 0. And let's solve. So for that one, let me create some space here. Let's see, I add, oh wow. Sometimes I get upset at my technology. I don't know about you guys. Like it hacks me all the time. So here I add 1, x equals 1, minus 5, x equals negative 5. And what are these? My roots, or my zeros. Are we there so far? So once again, step 1, is it in standard form? Yes. Step 2, we use the discriminant to find out how many zeros do we get. 2? Did we get 2 roots? Yes. Step 3, we use the beginning part of the quadratic formula with the denominator to get our x value of the vertex. We substitute that into the original equation to get our y value of the vertex. From there, we solve the equation to get our roots. Step 6, we graph. Let's use all that information. Let's see. I'm going to start with my y-intercept. I'm going to do that in green. Let's look at our equation. What's my y-intercept? Negative 5. Let's plot our point. That's right here. All right, so we got our y-intercept, negative 5. It's always the constant. Remember that? Step 2, let's see. I'm going to get my roots. What are my roots? 1 and negative 5. I'm going to do that in red. 1 and negative 5. There they are. My vertex, I'm going to sketch that in blue. It's what? Negative 2, negative 9. Negative 2, negative 9 is about right there. And it looks like, let's see, what coefficient does this one have? It's a positive. That means it's going to be opening up. Is that correct? So therefore, for this one, let's sketch it. I'm going to sketch it in black. I'm going to start on this side that has more points. I'm going to go slowly through those points. And after I hit that point, I need to come back up. There it is. It's always going to curve. Yes. All right. Copy that. All right. So let's see. Once again, standard form, yes. Discriminant to find out how many roots, yes. Use the front part of the quadratic formula to get our x value, yes. From there, substitute into the original equation. We get our y value for the vertex. There it is. Next, we solve the quadratic equation to get our roots. There it is. Step 6, we graph. There it is. And step 7, check this out. Pens down, eyes up here. I need to sketch the axes of symmetry. You're saying, what is that? Well, let me show you. Notice on my coordinate plane we have x-axis and y-axis. Is that correct? So what they're saying, for this parabola, there's an actual axis that if it cuts the parabola in half, that makes everything symmetrical. Who's tripped out? I'm pretty sure you've never done it, but I'm going to say that I did it. Who's been in the mirror sometimes that you're combing your hair and then all of a sudden you're going like that and you trip out at the distance from yourself in the mirror and the mirror image to the mirror? Has anybody tripped out on that? Yeah. No, I know you guys never did. Yeah, it's me. My bad. This is the same thing with the line of symmetry for the quadratic. And the line of symmetry is a vertical line that goes through the vertex. So check this out. The vertex is right here, isn't it? So the line of symmetry is right here. I'm going to make it dotted so you guys can see it. That's the line of symmetry. Sketch that, please. And this is what it does. The line of symmetry, nice and straight like mine. The line of symmetry, what it does, it shows us that the points on one side of the parabola are exactly symmetrical to the other points. So check this out. I want to check first my roots. Let's see if they are equidistant from the axis of symmetry, or the same distance. Let's see. Here's my line of symmetry. Everybody look up, please. Here it is. I'm going to start here. I'm going to look at this root. How many steps is it away from there? 1, 2, 3. Let me look at the other side. 1, 2, 3. Oh. Which means that how far is the y-intercept from the line of symmetry or axis of symmetry? 1, 2, which means there has to be a point on the other side 2 steps away from the axis of symmetry. Yep, there it is. Isn't my parabola going through there? Yeah. So basically what it's saying is that the axis of symmetry shows us that if there's a point going through here 1 step away, then therefore there has to be a point 1 step away on the other side for your parabola. Everybody with me? That's why when we were graphing yesterday, what happened after we hit 0? That the numbers repeated, didn't they, on some of them? That's what happens. The numbers are about the same. Okay? Any questions so far? All right. I know it's a lot for one, and the homework's not going to be as intricate. Okay? For some of them, they're just going to ask you, for example, everybody look up to the screen. For some of them, they're going to ask you, given the equation, how many roots, without solving it, how many roots are you going to get on this equation? So what step would you do? Step 2, because this is going to tell you how many roots. Using the given equation, can you find the vertex? What step would you do? 3, because this is going to give you the vertex. But if they ask you to graph using all those parts, we already have them. Are we there? Okay, example number 2. Copy this down, please. We're going to go a little bit faster, so make sure you tomato up. Example 2. You don't have to copy the text anymore. Just copy the equation. Y equals x squared plus 6x plus 8. X squared plus 6x plus 8. So let's do this one together. Step 1. Is it in standard form? Yes. Step 2. Let's find out how many roots. Yes? So turn to your neighbor, let them know what you write there to find out the roots. I heard b squared minus 4ac. Okay, which is the discriminants, right? So let's see. Destiny, what do I write? 6 squared minus 4 times 1 and 8. Okay, so far so good. This is 36. Negative times a positive and a positive, still a negative. 4 times 1 and 8, that's 32. And what is this? 4, it's a positive, so therefore it's a positive, it's 2 roots. So make sure at the end we have 2 roots when we solve. That was step 2, using the discriminant. Step 3, we need the vertex. Vertex, I'm going to write it here, vertex, open my parentheses. We need first the x value. So turn to your neighbor, let them know what are you going to write here to find the x value of the vertex. X equals minus b over 2a. Okay, so let's see. Negative times what? 6 over 2 times 1, which becomes negative 6 over 2, which becomes negative 3. That's my x value. So how do we find my y value? Substitute into the original. So I get my original, and that's step 4, to find my y value of the vertex. I get y equals, but instead of x, I'm going to write negative 3. Plus 6 times negative 3 plus 8. Y equals 9 minus 18 plus 8. 9 minus 18, that's negative 9, plus 8, that's what? Negative 1, that's my y value. So this is my vertex. I'm done with this. Okay, so that was step 4. Step 5, turn to your neighbor, know what step 5 is. Yeah, I can say. So we need to solve to find our roots. Okay, go ahead and do that, please. Okay, so I'm going to rewrite my equation. But instead of y, I substitute y for 0. That is x squared plus 6x plus 8. And then I open 2 parentheses, equal to 0. Power Ranger, we got 8, our product, 6, our sum. And what are our factors? 4 and 2. So this is x plus 4, x plus 2. Set each factor equal to 0. X plus 4 equal to 0. X plus 2 equal to 0. And then let's solve. Minus 4 minus 4. X equals negative 4 minus 2 minus 2. X equals negative 2, and these are my roots or my zeros. And once again, these are my solution. Is that correct? The solution to the quadratic equation. And let's see if your graph looks like this. Those of you that already graphed. My y-intercept, I'm going to do that in green. I'll do it in green. My y-intercept is positive 8, which is up here. My roots are negative 4, negative 2, negative 4, negative 2. Right there. My vertex is negative 3, negative 1, negative 3, negative 1. And here goes my parabola. And we sketch our line of symmetry, which goes down through the vertex. And hands if you did that by yourself. Okay? Okay, let's do another one. Isn't this fun? No? All right. Here we go. Example number 3. Example 3. You do this one by yourself. Once again, just to double check the steps before we get started with 3. Check for standard form. It's already in standard form. Step 2, use the discriminant to find out how many roots. Did we get 2 roots at the end? Yes. And by the way, just to label stuff, this point of my parabola is called the vertex or the minimum. Minimum, also known as the vertex. All right? So from there to get our vertex, we use the California part of the quadratic formula. We get our x value, substitute that into the original equation, get our y value. From there, we solve our original equation for the roots, and we graph everything, and then at the end, sketch your line of symmetry. Piece of cake? All right, Do this next one by yourself. Example number 3. Y equals x squared minus 2x minus 3. Go. Okay, so Luis said that first step he checked to see if it's in standard form. Since it was, he's going to step 2 to use the discriminant. Discriminant. Okay? Oh. To use the discriminant. And what is it? B squared minus 4AC. Okay, bless you. So tell me what to write. Negative 2 squared. Okay, and then this simplified to plus 12, which becomes, so therefore if this is a positive, it gives me 2 roots. Pass it to someone. Okay, Jose? Okay, California part. Negative B over 2A. Minus negative 2 over 2 times 1. Yeah, be careful with this one. Let me stop right there. Whenever you're substituting, remember, if there's negatives in between, open parentheses so you make less mistakes when you substitute. The other one, I went straight to just substitute and left it as a negative because they were all positive. Remember that? So make sure when you see negatives, start opening parentheses. Thank you. Continue, Jose. And this is 1. So my vertex, the first value is 1. Pass it to someone, please. Roberto? To the original equation. So he said we substitute that value. So y equals, what do I write?
Y equals x 1 squared minus 2 open parentheses 1 minus 2.
Okay, continue. Which becomes negative 4. So your vertex, check your vertex, hands if you got that. Okay? So from there, pass it to someone, please. Pass it to someone. Pete. Next step. The Power Ranger. So I rewrite again the equation. I bring it over, but instead of writing y equals, we write 0 equals x squared minus 2x minus 3. And did the Power Ranger, so he opens 2 parentheses. This one is x and x. What goes on top? Negative 3 and negative 2. So what are our factors? Negative 3 and 1. So this is x minus 3, x plus 1, and we set each one equal to 0. X minus 3 equal to 0, x plus 1 equal to 0. Let's solve. Plus 3, x equals 3, minus 1, x equals negative 1. These are my roots. Pass it to someone to help me graph. Roberto, go. The y-intercept is negative 3, and he got that from the constant of our equation, which is right here. Okay? The roots, negative 1 and 3. Okay, negative 1 and 3. What's our vertex? 1 and negative 4. And your parabola should look something like this, bless you. And our line of symmetry? straight down the middle right here. Okay? Yeah.